Hi everyone. So we're looking at question 3 from the Colourimetry question set. So what I've done for part A, I've already pre-drawn this graph. So we're looking at absorbance versus the volume of nickel that was added. And you can see that there are two lines of best fit. According to the question, you were asked to draw two lines of best fit. So the first line of best fit is for that data that is increasing absorbance as the volume is increasing. And the second is as that volume reached 4, the absorbance started to decrease. So for B, from the lines of best fit, determine the maximum absorbance of the complex and the corresponding volumes of nickel 2 plus and X minus. If we have a look where it intercepts, that is just after 4. So let's call that 4.1 mils of nickel 2 plus. And the maximum absorbance, if I'm just reading straight off the graph, and that is 0.9 there, I'm going to call that the maximum absorbance is 0.92. Depending on where your line intercepts, what we just want to see is that you're reading off of your data set. Okay, so the maximum absorbance might be a little bit lower or possibly a little bit higher, but that's all you really need to do there. Now, if you remember, the volume was made up to 10 mils every time. So to work out the volume of X minus in the solution, we'd go 10 minus 4.1, which is equal to 5.9 mils of X minus in the solution. So for C, what do we do with this information now? The solution of nickel 2 plus used in this investigation was prepared using 6.5 grams of nickel 2 chloride hexahydrate dissolved in 100 mils of distilled water. The solution of the ligand X had a concentration of 0.100 moles per litre. Calculate the number of moles of each reagent corresponding to the maximum absorbance and hence the formula of the complex. So if we just write down the equation of the formation of the complex from the beginning of the question, which is on the other side of the page, what we can see is that A moles of nickel 2 plus B moles of X form nickel A, X, B, and that is 2A plus will be the charge of that complex. Okay, so how do we attack this question? So what we know is that the nickel is coming from this nickel 2 chloride hexahydrate, and that's 6.56 grams. So if we write nickel Cl2, so the nickel we know has a 2 plus charge according to that information there of the valence. Now, nickel being a transition metal can have different valences, so it's given in the question here. Chlorine is in group 7, so the chloride ion will have a 1 plus charge, a negative 1 charge. So NiCl2, and then I do a little dot for the formation or the showing of complex 6H2O. So that's going to give us the information for the molar mass of nickel chloride hexahydrate. So 6.56 grams of that was dissolved in 100 mils. So to work out the moles of the nickel here, what we need to do is we need to divide that by the molar mass of this total complex. So nickel is 59.69, chloride ion will be 35.45. There's 2 of them. And water molecule, it has a mass of 18.016, and there's 6 of those. So what we end up with is a mole value of 0.02756 moles. It was dissolved in 100 mils. So to work out the concentration of this, it is that concentration equals N over V, so we divide that by 0.1, which is going to give us 0.2759 moles per litre. Okay, now so that's the concentration of the nickel 2 plus ion will be a 1-to-1 ratio, because you can see there's one nickel ion here. So the concentration of nickel will be the same as the concentration as the whole complex, nickel chloride hexahydrate. So then that's going to give us some really good information to work out the moles of nickel in this complex, which we're going to use the graph to do. So what we know is nickel 2 plus had a maximum absorbance at 4.1 mils. That's according to my information from the graph. Your value might be slightly different, which is perfectly fine. If it's 4.2 mils, if it's 4 mils, that's okay. Wherever the graph intercepted, wherever the two lines are best fit, intercept it. So 4.1 mils. So therefore, to work out the moles of the nickel 2 plus, then I'm just going to simply go N is equal to C times V, because I've got a concentration and now I've got a volume. So therefore, the moles of nickel will be equal to 0.2759 times the volume, which is there. So that's going to be 0.0113158 moles of nickel. For the ligand X minus, that has got, already we've been told in the question that it's got a concentration of 0.1. So once again, the N of X minus is equal to 0.100 times, we've worked out that the volume at the maximum absorbance was 5.9 mils. So we're going to multiply those two values, and what we end up getting is 0.00059 moles of ligand X. So I've done that. Moles of each one. Done. So the last thing we need to do is work out the formula of the complex. Okay, so this is where we're going to use our knowledge of empirical formula. So to work out the ratio. So the ratio of Ni2 plus to X minus to work out the formula is going to be, if we say 0.01135 divided by 0.0059, so to work out Ni2 plus over X minus is equal to 1.9. Or if I round, we can't have 1.9 as a molar ratio, so I'm going to round that up to 2. So then Ni2 plus to X minus is 2-to-1 ratio. Okay, so that means that if I substitute these values now, this becomes our A, this becomes our B. So now what I'm going to do is I'm going to rewrite it into this formula. So then you can just straight away see what the formula of the complex will be. So 2 nickel 2 plus 1x aqueous gives us nickel 2 x1, and then the charge is going to be 2AB. So 2 times 2 gives us a 4 plus charge, okay? And a 4 plus, you could also work that out by saying, well, if each nickel has a 2 plus charge and there's 2 of them, then it will be 4 plus. But I think it's really self-explanatory when you put it into the equation. And that is the formula. So that is the final answer for part C. Now, I think, look, in the HSC, this will probably be worth more than 3 marks, okay? But you've got to look at what you can do. So, if you look at this question and you're thinking to yourself, geez, this is a lot for me to unpack, at least if you worked out the moles of the nickel 2 hexahydrate and then the concentration, because you've got a mass, you can work out molar mass, and you've got a volume, you're at least going to give yourself a head start to get at least a mark or 2 there. Okay, so that's how we would tackle that question. and we'll talk soon. See you later.